Assalamualaikum and hello. In this video, this is the last part for our chapter 5 where I'm going to focus about example 1 until example 5, which I'm going to teach you the tips and technique to answer a few styles of questions that will be asked in your test. So we will go from the first example 1 until example 5. So let's do example 1 together with me. As you see here, you need to write the electronic configuration for sulfur at its ground state, where the proton number for sulfur is 16. If the proton number is not given in the question, you can refer to the table of Ferrum so that you can know the number of electrons for that element. So now we have sulfur with 16 electrons. What I'm going to do, I'm going to write electronic configuration at ground state. Ground state here means that there is no electrons are being removed or being added. So maknanya tak ada perubahan, neutral. So first thing first, you put the symbol for sulfur, and then the electronic configuration, I hope you start to memorize the order of lowest energy orbital until highest energy orbital. So I start with 1s2, 2s2, 2p6. So 10 electron already. I got 6 more left. 3s2, 3p4. So this is the electronic configuration for sulfur in form SPDF notation. How about in form of orbital diagram? So I can put also as orbital diagram. So for example, I use the line. So one line for 1s, one line for 2s, 3 line for 2p, 1 line for 3s, and 3 line for 3p. And after you complete the line, now I'm going to put the electron 1, 2. Positive half, negative half. 1, 2, 3. Follow Hans' rule. 4, 5, 6. 1, 2. And then we got 4 in 3p. 1, 2, 3, 4. So that's how you do the electronic configuration in form orbital diagram for sulfur. Let's go to the next example, example 2. I'm going to write the electronic configuration for aluminium. So right now I want to be specific, just one form only. So let's write in SPDF notation. I got 13 here is the proton number, as aluminium is the neutral atom. So the electrons also 13. So what I'm going to do, write a symbol for aluminium, and then I will start from 1s2, 2s2, 2p6, and then 3s2. So you got 12 already, one more left. It's going to be in the next subshell 3p1. So this is how you write the electronic configuration for aluminium at its ground state. After that, I want you to write the electronic configuration for aluminium ion, where 3 electrons are being removed from the valence shell. As you see here, 1s2 is going to be in the first shell, 2s2, 2p6 is going to be in the second shell, and 3s2, 3p1 is going to be in the third shell, and this is our valence shell. So I'm going to remove my electrons, 3 of them, from this valence shell, where you can see I got 2 plus 1, 3 electrons. So all electrons from the valence shell are going to be removed from here. So what's left? For Al, 3 plus, make sure you put the charge, is going to be 1s2, 2s2, 2p6. So this is your answer. Very easy. Next one, we go to the next example 3. I want you to write the electronic configuration for calcium where the proton number is 20. So I'm going to put the symbol for calcium, Ca. And we are going to start with orbital 1s2, 2s2, 2p6, 3s2, 3p6, and then, so as you can see here, the total electrons here is 18 electrons. So we got 2 more left. It's going to be in the subshell 4s2. So the total is 20. So right now, I'm going to write the electronic configuration for Ca2+, where 2 electrons are being removed from the valence shell. So from here, you can see that n equals to 1, and then here, n equals to 2, here, n equals to 3, and here, n equals to 4. So semakin tinggi nilai n, semakin tinggi energy level, and this is going to be the outermost shell. Maksudnya, the valence shell. So I'm going to remove 2 electrons from 4s orbital. So what's left right now is Ca2+. Make sure you put the charge. 1s2, 2s2, 2p6, 3s2, and 3p6. So that's it for electronic configuration of Ca2+. Next one, we go to a bit more upgrade where I use ferrum right now, which is one of the transition metals. So I'm going to write the electronic configuration for ferrum first, because right now the question asks for ferrum 3+, but it's much more easier for you to write as general first. So saya akan letak ferrum as ground state. So the proton number is still 26, and then I'm going to start with 1s2, 2s2, 2p6, 10 electrons, and then 3s2, 3p6, 4s2. So right now 20 electrons, and then after 4s orbital, we are going to fill the electrons in the next subshell, which is 3d. So it's going to be 3d6. And then, as you know, the maximum number of electrons that can fill in the d orbital is 10 electrons. But right now, what's left from ferrum adalah 6 sahaja. So that's why dia stop sampai 6, 3d6. And the next one, it asks you to remove 3 electrons. So these 3 electrons are going to be removed. So how you want to do that? Please remember that the tip that I teach you in the previous video, once our isi electrons dalam 3D, 4s akan repel kepada higher energy. So maksudnya dalam kes ini kita akan buang 2 elektron yang pertama daripada 4s, followed by 1 electron daripada 3D. So the electronic configuration for Fe3+, the proton number stay 26, is going to be 1s2, 2s2, 2p6, 3s2, 3p6, and then there is no more orbital 4s because we remove 2 from 4s and 1 from 3d. So what's left adalah 3d 5. So this is the electronic configuration for Fe3+. Make sure you remember ini special case hanya untuk transition metal sahaja. Kita akan remove daripada 4s dahulu barulah 3D. Tapi bila kita isi elektron, kita masih perlu follow aufbau. Kita isi dalam 4s dahulu barulah 3D. Settle for example 4. And the next one, we are going to continue with the last example, example 5. Where example 5, element P has 14 electrons and 1 electron has been removed to form ion P. So you have to write the electronic configuration of P, question A. Question B, give one set of quantum numbers for last subshells of ion P. And C, you have to draw the orbitals that accommodate valence electrons for ion P. So let's go to the first question, question A, where you have to write the electronic configuration of P. So P has 14 electrons. It means that this is the neutral ataupun ground state untuk P, di mana dia mempunyai 14 electrons, also 14 proton number. So I will write it down. P, the symbol, and then you have to start your electronic configuration with the lowest energy level, 1s2, 2s2, 2p6, 3s2, 3p2. So the total of them, 2 plus 2 plus 6 plus 2 plus 2 is 14 electrons. So settle for question A. Next one, you have to give one set of quantum numbers for the last subshells of ion P. So we know that element P has 14 electrons. So this is the electronic configuration for P. 1s2, 2s2, 2p6, 3s2, 3p2. But now the question asks you to give one set of quantum number for the last subshell of ion P. So, mesti kita buat electronic configuration untuk ion sekarang. So, it's going to be P and one electron has been removed. It means that the charge is positive and the electronic configuration is going to be 1s2, 2s2, 2p6, 3s2, 3p1. So itu maksud kita buang daripada last subshell. Okay. So now we are going to continue with one set of quantum number. So one set of quantum number ini dia fokus kepada bahagian last subshell. Maksudnya awak tahu n yang paling last adalah n equals to 3. But right now, I just want you to focus for the last subshell dalam n equals to 3. So, kita ada dua subshell. Subshell 3s dan subshell 3p. So, maknanya yang mana yang paling last, 3p adalah the last one. So, it means that, so I want you to write the set of quantum number for 3p subshell. Okay, so what will happen? Take out the information that you have, 3p, where n equals to 3, as you see here in front of it. And then the L value based on p orbital adalah L equals to 1. And then your m value can be -1, 0, +1. And your electron spin S value can be +12, -12. So the next one, how you want to write one set of quantum number. Please remember, I taught you how to write a set of quantum number based on acronym nasi lemak masak sambal. So, you are going to use that acronym in bracket nasi, lemak, masak, sambal. NLMS equals to the value that you will put in this bracket adalah berdasarkan 3P that we listed down here. So we got 3 for N. So 3, we got 1 for L. So 1, and then you got 3 values for M, but you cannot use all of them because I just want one set. So meaning you will just choose whichever one of them only. So saya put, for example, I take 0. So 0, and same with electron spin. You cannot use both of them. You just use one of it. So you can put positive half. And close your bracket. So this is going to be one set of electrons. Sekiranya awak ingin tulis all of them, 3, 1, -1, positive half, 3, 1, -1, negative half, awak boleh tulis, awak boleh buat sambungan daripada sini, tapi before awak sambung antara bracket kepada bracket, you have to put a special word iaitu or, atau. So saya tak akan tunjuk di sini supaya bila awak buat latihan, awak akan faham apa yang perlu awak lakukan. I just show you the basic example only from here. So let's continue. So settle for question 5B. Now we are going to continue with the last question. You have to draw the shape of orbitals that accommodate the valence electrons for ion P. So as you know before, ion P is P+. We got 1s2, 2s2, 2p6, 3s2, 3p1. So how you want to draw? You have to draw based on the valence electrons. So maksudnya valence electron adalah daripada shell yang terakhir, iaitu n equals to 3. So this is your valence shell. Automatically, in n equals to 3, we got 3 valence electrons. So electron yang kita akan lukis, as you know here, we got 2 in subshell 3s, we got 1 in subshell 3p. So maksudnya saya perlu lukis which orbital? So kita perlu lukis both of 3s orbital dan 3p orbital. So I continue from here. We got 3s2, 3p1. So one of them for 3s orbital dan another one more adalah untuk 3p orbital. So macam mana saya nak draw? So seperti mana yang awak sudah belajar daripada chapter sebelum ni, kita akan draw axis dahulu for x, y and z. So I got this one y, this one z and this one x axis. So what will happen, saya draw untuk 3s orbital dahulu. So this is 3s. Saya terus label supaya saya tak tertinggal. Right now, be specific sebab dia beri nilai n. So, perlu letak 3 dekat depan. And continue with the shape for s orbital. Shape dia adalah spherical. So, maknanya saya akan lukis bulat dalam bahagian drawing sini. And then, jangan lupa shade your orbital. So, settle untuk 3s2. Maknanya, 2 elektron boleh accommodate dalam area sini. Now, I'm going to draw another one more, iaitu 3p. Tapi apa yang kita lihat dekat sini, kita ada 1 elektron. So, macam mana awak nak tentukan 1 elektron ni dalam which orbital? Sebab kita ada 3 orientations untuk P. Px, Py dan Pz. So, to be safe, you draw all of them. And then, when you draw all of them, make sure you put the axis. And then, this is going to be 3ps. This is going to be 3py. And this is going to be 3pz. So, based on your labeling, you are going to use this labeling as your reference. So, kita akan draw based on labeling. 3px maknanya dumbbell untuk saya punya shape P orbital akan berada di atas axis S. So I'm going to draw it right now. So starting from the center, 1 loop, 2 loop. Make sure you shade the orbital. So settle for 3ps. The next one, you are going to draw for 3py. And shade. And last one, you are going to draw for 3pz. And make sure you shade the orbital. So, apa yang awak boleh relate dekat sini, one electron daripada p orbital ini boleh berada dalam 3px, boleh berada dalam 3py, boleh berada dalam 3pz. Tapi macam mana kita mahu confirmkan? So, benda yang awak perlu faham, kita kena letak satu ekstra perkataan untuk membezakan sama ada dia boleh berada di dalam sini, situ atau sini. So, awak mesti letak perkataan or atau or supaya examiner tahu one electron can be here or here or here. So I hope you clear with this kind of question style untuk jawab dalam chapter 5 ini. So make sure you try this 3.0. The next one, try this 4.0. And last one, try this 5.0. Please try this. Okay, cuba jawab supaya awak faham apa yang awak belajar dan awak boleh aplikasikan ilmu yang awak belajar. And now we settle for chapter 5, electronic configuration. You're done. So make sure you try to do your best to learn. Tolong kuatkan semangat because Miss percaya awak semua boleh buat. And make sure you complete all tutorial questions and submit them before the deadline. Tapi pastikan bila awak submit, awak mesti letak jawapan awak yang sudah ditanda. So how to do that? You can discuss with your friends or you can ask your lecturer for answer scheme. But at least after you're done with the exercise. So that's all from me. I hope you can do your best for chapter 5, electronic configuration, and I'll see you in the next chapter, chapter 6, which is about periodic table. So thanks for watching until now. See you next time. Bye.